All right, we continue with security, still using the slides from Computer Networking, a top-down approach book. So, the name of our course, Network Security, and why we need it. The problem is that Internet not originally designed with much security in mind. Because original vision was that a group of mutually trusting users attached to a transparent network. So now it sounds funny, I know, because nowadays we almost trust nobody on the internet. Internet protocol designers playing catch up, security considerations in all layers. So we observe a problem, we try to solve it. Years ago, at some point, we said that internet is broken. Let's rebuild it, because the spam emails were so annoying that we couldn't get rid of them for a long time. Luckily, at some point, other than rules, we can avoid spams, but good filters by machine learning and so on. So this is why we can actually send each other emails nowadays. Like 15 years ago, it was a real problem, and there were some ideas like maybe we should charge 1 cent for every email that's sent and so on. So still, of course, internet is not as that secure. We have observing a lot of problems, but we are trying to come up with solutions. We now need to think about how bad guys can attack computer networks, how we can defend networks against attacks, how to design architectures that are immune to attacks. So, one example is, what can a bad guy do is as follows. Packet interception. We call this packet sniffing. Since we are doing a broadcast media, for instance, if you are using wireless communication, you're just broadcasting it on the air. So it is very, very easy to listen to this communication. All you need is the proper antenna, right? Because it is distributed wirelessly. But similar thing happens at shared Ethernet, because in the Ethernet, it is still a broadcast media. For instance, here it says promiscuous network interface reads, records all packets, for example, including passwords passing by. So what does this mean is as follows. Assume that your person C, your laptop or desktop is C, and there's some other people on your network, okay? Normally, what C does is follows. When it receives packages, your network adapter actually looks if the packet is sent to you or not. Otherwise, they will drop it. But if you turn your network adapter to the listening mode, which also referred to as promiscuous, if you're using Wireshark and so on, then you can actually record every packet on the network to your memory of your computer so that you can then analyze it. So software like Wireshark actually does this. Here there is a catch. You can install Wireshark on any operating system like Windows or any Linux version. But the thing is that Microsoft Windows does not allow you to, turn your network adapter into the listening mode. So you cannot just record other people's communication. So this is why actually hackers or pen testers and so on use Linux operating system for this kind of operations. Here the picture says, so if this is a malicious person, even if the destination is not C, source is B and the destination is A, and at the end there's the payload, C can actually capture this packet. Wireshark is a free software which we also use in our penetration testing courses and so on. So another thing that the bad guy can do is perform or have a fake identity. This is done by IP spoofing, injection of packet with false source address. So ID is as follows. When you create a packet, actually it contains the source and the destination. Since here the source is C, your network adapter actually writes C here. But since you have the control over your network adapter, you can actually write B here. So if it is going outside to the internet for other computers, actually here ISPs should check if the provided source IP is really coming from there. This is just a configuration error. But inside the network, C might, act like as if it is B and try to send a payload to A. This is called spoofing. Injection of packet with false source address. Denial of service attack. This is what a bad guy can do, and it is currently very famous, and there are many methods to do it. Attackers make resources, server bandwidth, unavailable to legitimate traffic by overwhelming resource with bogus traffic. So here's the target. You select your target, and you somehow, inject malware to a lot of computers and turn them into zombies. So we call them a botnet. Then you can command these computers, and you can just ask them to send the packet to this target. Since all of these computers are compromised, they wouldn't know that, and they will attack the target. So since this is a distributed denial of service attack, it is a little bit harder to overcome this. So lines of defense, as you can guess, authentication, proving you are who you say you are. Cellular networks provide hardware identity via SIM card. No such hardware exists in traditional internet because we don't provide that kind of hardware to every user. Confidentiality. Thanks to encryption, we solve this. We have very nice encryption algorithms, and we can overcome this problem. Integrity checks. Digital signatures prevent or detect tampering. Access restrictions, password protected VPNs and so on. Firewalls, specialized middle boxes in access and core networks. Off by default, filter incoming packets to restrict sender receivers applications. Detecting, reacting to denial of service attacks. And lots more on security. So this is in the book covered in chapter 8, but we are going to talk about all of this in detail because this book is about, computer networking. Security is just a part of it, but for our course, we are focusing on, security, network security. So we will talk all about them in detail, starting with cryptography, encryption algorithms, authenticated encryption message authentication codes, digital signatures, and so on and so forth. These are the things that we are going to cover when we talk about cryptography.